Okay, we have work to do, and that is going to be practicing some Lewis dot structures. In that effort, I want to point out there are 4 of these that are going to be a little bit more challenging. I'll give you some help with those. But let's quickly review what the game plan is for Lewis dot structures. First of all, they are a 2D dimensional view, so they're not completely accurate, but it gives us an idea how the elements are arranged in space. They come from dots, which are valence electrons. I gave an example here of boron is in the 3rd column, so it has 3 dots. Also, fluorine is in the 7th column and therefore has 7 dots. Notice the electrons are arranged in north, south, east, or west locations. Now, moving forward, when we make compounds, we like to have the electrons, or actually I should say each element have 8 electrons around it, or 2 in some cases. Also, we can have bonds by sharing. Of course, that's the goal here. And we could have single bonds that share 2 electrons, or double that share 4, and of course even triple. No more than triple though. Okay? So I want to show a few of these and their answers, just because they are a little bit beyond what we're doing right now. How are they beyond? They're beyond on this category. Some of these will have more than 8 electrons around them, which it happens, but since 95% of Lewis dot structures do not have more than 8, we don't spend a lot of time on those. So let's look at these 4 which actually do. Okay, so I'm going to look here at PF5. When we do this PF5, we're going to find out that since there are 5 fluorines, that phosphorus will take its 5 electrons, and instead of going north, south, east, and west, it will actually end up doing something like this. And these become the bonding sites for where fluorine comes in. That's not a good color. Fluorine will come in here, the 3rd one there, another one here, and finally the 5th one up here. And then the dots are shared, so there's the sharing. And fluorine has 7, so 2, 3, 4, 5, 6, 7, and we could do this in all of these. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and there's the 7th one's there. 1, 2, 3, 4, 5, 6, like this. Okay. This iodine way over here on the right also does the same thing. It's not iodine, it's iodide. It's actually like a triiodide. And this ends up forming like this follows. 1, 2. Now remember, I'll erase this real quick, that iodide likes to have 7, so 2 are here, 3, 4, 5, 6. Okay. And in this situation, here's our 6. See this negative though? I should have probably done this better. I should go back. Because of this negative, I can put that extra electron there. Maybe I should give it a special color, like yellow. Okay? Now, the other iodide comes in here and here, straight across. And the electrons for that we'll do is red. So here's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right? So I'm not so much worried about these extreme cases like these, but I do want us to do these other ones. So NO. NO is also an oddball. So that's today's goal, is to see some more strange ones that maybe aren't exactly the same. So nitrogen and oxygen. If you had a piece of scrap paper, you could probably be like 1, 2, 3, 4, 5 for nitrogen, oxygen, 1, 2, 3, 4, 5, 6 here. And it's going to be, unfortunately, it's going to be impossible to get 8 around each. So we're going to get 8 around oxygen, and we're going to do it like this. This little opening, this electron here is going to move to this position, and this electron is going to move to this position, and then these two elements are going to come together. So let's see if I can draw that. So I'm going to have that one, so I have electron, electron, one electron here, 1, 2. Now let's do the oxygen's electron, so I moved that one here, and then I have bum, 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 bum. Okay, this is the best we can do with this one, where we have 8 around the oxygen, but we do not have 8 around the nitrogen, but we do have 7. Okay, I'm trying to get rid of some of the challenging ones so you guys don't have to do them. I think this one's going to be pretty simple. This one's going to need a double bond. This one you actually remove an electron, so it turns out to be pretty simple when you remove one electron from nitrogen. This one's, we've actually done a cousin of this, so this one down here will be very simple. We've done a cousin. This one's pretty straightforward. Won't get 8. BRF. This one is just like, it does the same kind of thing that iodine did up here, where it flares out the double pair here, and then it's single, single, single. So if you start there, you should be fine. Okay, CO2 with the extra electron. This is clever. Maybe I'll do this one. Okay, so let's do this one right here, this CO2. All right, we have carbon. Again, I'm going to just do my thoughts over here. 1, 2, 3, 4, and we know we have 2 oxygens. Oxygen, 1, 2, 3, 4, 5, 6, and another oxygen. 1, 2, 3, 4, 5, 6. We also maybe know that carbon dioxide looks like this. Okay, so this might be our big help. All right, and they said CO. I'm sorry, this is a mistake here. Please fix this real quick on your papers. Adjust this. This should have been CO3 negative 2. Sorry, CO3 negative 2. I didn't fix it on the copier, so that means we have another oxygen that needs to be accounted for. These are hard, but I think seeing these and doing them, that's why I'm giving notes on them, is going to be helpful. All right, I'm going to do the following. I'm going to know that carbon likes to form 4 bonds, so 1, 2, and I'm going to have a double bond. That's my big clue, is knowing that carbon likes to form 4 bonds. So now I'm going to come in with oxygen, here, here, and here. I'm going to make this a double bond because that's what carbon needs to have happen. I'm going to use my 6 electrons there. These are going to be single bonds, but this oxygen will have 1, 2, 3, 4, and remember this one that I used earlier, 5. So here it says 6th, and I do the same thing up here. I already have 1 in the bond with carbon, 2, 3, 4, 5, 6. But notice I get to use 2 free electrons here and here. Now I've got 8 all over the place. Why 2? Because this is negative 2. Okay, I think the ones at the bottom are pretty straightforward. If you check your notes, carbon monoxide, you should be able to find that. BRF5 and BRF3. This one is just like the PF5 that we did at first. All right, give it a go. Do your best.